Welcome back to the Sense of Security podcast. I'm Cassidy Clement, Senior Manager of SEO and Content here at Interactive Brokers, and today I'm your host for the podcast. Our guest is Ernie Chan, Chief Scientist at Predictnow.ai and founder of QTS Capital Management. You may not realize it, but machine learning is used in the financial service industry within features, tools, and decision making. In this episode, we're going to try to break down machine learning and then also mention its use cases. Welcome to the program, Ernie.
Thanks for inviting me, Cassidy. Great to be here.
Sure. Of course. So, since this is your first episode on Sense of Security, why don't you tell our listeners a little bit about your background and how you got started in the industry?
Sure. I actually started my career as a machine learning researcher at IBM TJ Watson Lab up in Yorktown Heights, New York. My specialty in my group is researching language modeling, which is essentially what OpenAI is doing today, except it was a few decades ago. So I was happily researching how the computer can understand human language, understand speech, and speak to people in natural language. When some senior researchers in our group decided to decamp to a hedge fund, which shocked all of us because we never thought that what we do have any relevance to financial markets. In fact, I am completely clueless as to how to trade stocks and what are the options and all that nice stuff at that time. But it turns out that these senior researchers became very successful. They went on to a hedge fund called Renaissance Technologies and rose to become co-CEO of that company. And that fund, of course, turned out to be one of the most successful quantitative hedge funds. So I also became curious and I decided to explore applying machine learning to finance and asset management at that time. And I went to Morgan Stanley AI group, which was just started about a year before I joined. And there was only 5 or 6 people in that group at that time. Now I heard there are over 1,000 headcount. So it was quite a journey for machine learning and AI in finance, just looking at the growth of headcount in the group that I joined before. So after that, I worked for a number of different banks, Credit Suisse and others, and hedge funds until about around 2011. I decided to start my own quant fund and QTS Capital, and it's still going. But a few years ago, I decided that my true passion is really on machine learning research. Running money is fun, but sometimes I think I want to go back to my roots as a researcher in machine learning, and I started a new company, Predictnow.ai, which research methods of adding value to the asset management and trading process using AI.
Well, given today's topic of machine learning and finance, you seem to be the perfect guest. So, when we jump into this from the beginner perspective, before we get into the real meat and potatoes of this conversation, what exactly is machine learning and what's machine learning in finance? Maybe you can give some use cases as well after the definition. I think a lot of people don't realize how much it's utilized in so many things that seem so basic.
So I would draw a contrast between machine learning and expert system. So a lot of people, you remember maybe some years back, the IBM machine Deep Blue was able to beat Gary Kasparov in chess. I remember that very clearly because I just left IBM at that time very recently. So everybody was talking about amazing that the Deep Blue can beat the reigning grandmaster. But interestingly, a lot of people thought of that as an example of AI. Well, it is an example of AI, but it's not machine learning because the way that they beat Kasparov is actually to embed a lot of man-made rules in the machine, hard-coded rules. If this person make this move, you should make that move, and it's just a lot of hard wiring. It doesn't actually learn by itself. It's a lot of experts coding this machine so that it can beat the grandmaster. And it's a great, piece of code, but it's not machine learning. What machine learning does is much more similar to what DeepMind, which is now part of Google, what DeepMind did to beat to play Go. That's true machine learning because there's nobody who actually write codes to tell the machine what to do when a certain chess move come. It all learn by itself. It learn by example. So machine learning essentially is teaching the computer to learn on its own from examples. And that is part of AI, but it is the kind of AI that is much more powerful and much more effective these days than the old paradigm, which is expert system, where people have to hard code rules. To answer your second part of the question, what are the use cases in trading? Well, of course, the most obvious one would, most people would think, oh, we should teach the machine to predict the stock market, right? But actually, that's the hardest use case for machine learning because, as I mentioned before, machine learning depends on data. So it learns from the data. But in the case of, let's say, predicting the market, everybody's looking at the same data, right? And all the data are public, whether it's earnings report or prices or the macroeconomic indicators. Everybody essentially have the same information. And frankly, there aren't that many machine learning algorithms out there. And so you are really training robots against robots. And as a result, a lot of the times what you are learning and producing are competing against each other. And also what you're learning are historical patterns. And everybody exploiting the same historical patterns based on the same algorithm, they result in a arbitrage where this pattern disappeared. So a lot of times predicting prices or returns is the most difficult task because of arbitrage in the market. But there are other ways to exploit machine learning in trading that is less subject to this dynamic. One is, for example, sentiment analysis. A lot of times people read what the CEO had to say about that company, and they form a certain judgment. And different people might interpret it differently, but they would use this kind of judgment or sentiment as part of their input to their investment decision making. And machine learning can definitely make this much more efficient. So instead of having a investment analyst to read the speech or read the earnings report and form a judgment, the machine can immediately form a judgment in a split second based on language model, natural language understanding. Now, that doesn't necessarily mean that the machine can then make an investment recommendation. No, but it can use as an input, which essentially automate the task of a lot of investment analysts and make it much more efficient. It is used that way, and it is just used as one of the inputs to the investment decision making. That is less subject to arbitrage because everybody have a different investment decision making process or algorithm, and this machine learning is only creating one of the inputs among many. So that's one way. But what we think is the most powerful application of machine learning to trading is actually not in direct decision making, but in risk management and in capital allocation. We find in those two cases, the problem of arbitrage does not exist because when we are talking about risk management, we are trying to detect the risk of a particular portfolio or particular investment strategy. And everybody have their own portfolio and their own investment strategy. If you can say that, well, my machine learning program tell me that the probability of loss of your current trading strategy is very high, well, don't trade. That doesn't affect anybody else. Nobody is competing with you because nobody even know what your trading strategy is. You are really learning from your private data, unlike trying to predict Tesla's return. That is a public data. But in this case, we are trying to predict whether your own trading strategy is going to be profitable. That's private data. Nobody can see it. Nobody, even if they see it, they can't do anything about it because they are not trading your strategy. So risk management is one of the few areas where machine learning can make an impact on trading without suffering arbitrage. And similarly, capital allocation is another one. If you have 5 trading strategies, which one you should trade in a bigger size, which one you should trade in a smaller size, the machine can use the contextual information such as the economic environment, the market environment, the historical behavior of the different strategy to make an optimal allocation. And again, nobody can compete with you on that because they don't know what your five strategies are, and even if they know, they can't do anything about it, because you are the one trading them, not them. So these are the cases I would favor as a better use case of machine learning than the more sort of obvious use case of predicting returns.
I mean, from what you had mentioned too, it's not necessarily every use case is an easy application or every use case is an extremely hard application. This kind of leads me into my next question, which is, most people, when they think about machine learning, at least in today's day and age, they're mainly thinking about people in terms of working on machine learning. They're mainly thinking about people like data scientists, maybe quants, or people who are on the day to day with large data sets applying them. So, who exactly are the people utilizing this data or the software within the financial services industry or financial services companies?
Mhm. Traditionally, investment banks or hedge funds hire quants, and they tend to have a physics background or mathematics background, and they like to use a lot of high-powered analytical models, Black-Scholes models, common toolbox for valuing options, and so forth. They like to do things analytically, but as more and more of these models show their limitation, they have migrated also to much more of a data-driven approach rather than a analytical approach. So in this day and age, when a hedge fund hire a quant, it's very unlikely that this quant would not have a machine learning knowledge. So essentially, every quant nowadays know both the basic math that traditional quant know, and also they know how to apply machine learning to finance. It is basically a part of the required curriculum of quantitative finance in any school at this point.
Well, when we're talking about all of these aspects with curriculum as machine learning, and I mean, AI is another thing. We just recorded an episode on that. There's so much involving large models, large data being woven into all aspects of education, including the obvious spots, like you mentioned, quantitative finance, computer science, physics, things that we know are traditionally steeped in math. But for those just looking to get an overview or get started in learning more about machine learning and machine learning in the financial industry, are there certain resources you can suggest or certain places that people could be watching, listening, learning about these topics?
Well, at the risk of advertising that or tooting my own horn, I have written five books on quantitative trading, and many of my later books, such as a book called Machine Trading, increasingly talk more about the application of AI to finance. So my latest book is called Generative AI for Trading and Asset Management, which I co-author with a great friend of mine, Dr. Hamlet Medina. And I learned a lot actually from his writing in how a lot of the deep learning technology that is being used by OpenAI in language modeling can be applied to trading asset management. I was like taken aback how much advance AI has made that is applicable to all things, not just about language, not just about images, but about finance, for example. So they are the traditional machine learning algorithm that everybody have learned 10 years ago, and there's this sort of generative AI algorithms that only really deep learning researchers know about in the last few years. But now, even though deeper layers of machine learning are being brought to bear on asset management. So our books hopefully will provide a introduction from both the basic techniques to the most complicated ones, so that people can learn as they progress in this field.
So, as people start to learn about the different aspects and maybe use features or tools that mention that they use machine learning in them, what are some things that people should listen or ask questions about, think about, keep in mind when they're exploring adding these tools or machine learning in general to their financial strategy and applying it?
Well, I think that when one applies machine learning to trading in the financial market, one has to always bear in mind the possibility that the market is not stationary. So unlike applying machine learning to language, let's say the program try to read every Wikipedia page so that when you ask it any questions, it can provide an intelligent answer. And those answers are unlikely to change very rapidly. You can ask about science, you can ask about history or philosophy, and those things typically don't change very fast. Maybe 10 years later, we'll have a new understanding of what the atmosphere of Uranus is. Yeah, okay, well, that will change. But in the financial market, obviously, things can change quite abruptly. You could have a pandemic that completely disturb the market environment. No one ever seen that before. You could have a mortgage crisis that pretty much made it almost impossible to short any stocks because the SEC prevented you from doing so. In the financial market, it is a environment where it is very dynamic, and because machine learning essentially need to learn from the past. And if there are a new environment where we have never seen before, let's say, climate change rendered none of the houses in Florida insurable. How does that affect the real estate company? Nobody have seen this before. So that's the risk of applying machine learning in finance is that, well, the major assumption is that, you have enough data so that you have seen everything. But there may be cases that you have actually not seen. And that would be the downfall of your algorithm if there's no sort of guardrails provided.
So you mentioned there that there's the element of the unknown, which we all know the market is never perfect. No one has ever said everything that I say about the market is perfectly correct. That doesn't exist. So, other than the unknown aspect of the markets, are there other pitfalls involved when applying machine learning to your financial strategy or when creating a data set and trying to allow the system to learn from it?
It's interesting that you mentioned data set. And in addition to this fundamental problem of, the world being always changing, there are specific problem on financial data set. And that is a problem that we call not having a point in time data set. So a lot of times when you look at financial data, they have been revised. A lot of times, for example, a company publishes an earnings report and maybe a quarter later they found some accounting problem and they would change the numbers, and then that number will be posted to the database. If your machine learning algorithm pick up these revised report and learn from them, um, it would actually produce a model that you would think, well, of course we should use the correct number, right? Why should we use the incorrect number to train the model? But unfortunately, when you actually apply this machine learning model in a live trading situation, it is encountering the first report, the uncorrected report, and not the one that would come out 1 quarter later, the corrected report. So, it is a very subtle problem that a lot of people outside of finance, but who are machine learning expert, did not realize is that you actually want data that is so-called bad data. You want to train it with data that is full of errors because that is the data that you are going to get fed into your live trading program, not the corrected data that happened 3 months from now.
That's a really interesting aspect. I remember in my statistics classes in college and my computer science classes being told, junk in, junk out. However, machine learning and AI, it brings a whole other level into perspective because you're trying to make the machine learning and the AI emphasize human like qualities within a machine, which, as most of you know, Thanksgiving is coming up as we're recording this. I'm sure many of you are going to have conversations with your family members where you're like, that is so incorrect. And that's the point. A lot of data that gets fed into these models is incorrect. So it's important to test with incorrect data to see how things can be adapted to give corrections and give answers that do allow for an error margin to be supplemented and adopted to make the answers a little bit more tactile and malleable. So I guess we talked about the basics, we talked about the good, we talked about the potential bad, but coming up in the world, what's the latest frontier? What's going on the cutting edge in terms of machine learning?
Well, I would say that the latest and greatest machine learning research is, not surprisingly, being conducted in the language modeling space. We have OpenAI being valued at what 115 billion, while it's still losing money and that sort of thing. And so you have the world greatest some computer scientists working on this. So it's no surprise leveraging that kind of research. Cutting edge research being conducted in language and image processing space, and see if we can learn some lessons to apply to asset management and trading. You can say that we are, in some sense, followers rather than leaders in machine learning research. And that is just fine because obviously there are probably 10 times, maybe 100 times more researchers doing language modeling research and doing machine learning research in finance. So it's okay to learn from them. But there's so much to learn. The amount of research output is just incredible. You could just spend every single waking hour of your day reading papers, and you still wouldn't be able to finish them. And so one has to really learn how to learn. It's a meta learning problem. What paper I should read that could be of value to the trading problem, and then that's the problem I'm confronted with. I'm trying to learn. But some of the key insights that was being extracted in the last few years comes to mind is that, for example, the transformer technology in deep learning had proved to be extremely powerful, and many financial researchers are adopting it to time series analysis as well. So I would say the idea of using transformer is a key insight that practically every financial researcher are considering to adopt. And then, of course, reinforcement learning. I went to a conference last year at UC Berkeley. It is on finance, quantitative finance, and practically every other speaker is touting how amazing deep reinforcement learning is. So that's something we are exploring also in Predictnow. Deep reinforcement learning, as you know, is the algorithm behind the DeepMind's AlphaGo program. How they defeated the best Go player in the world. That was using deep reinforcement learning. Playing Go has and other games have some resemblance to trading, because in trading, of course, it's a much more difficult problem because you're not playing games against one person. You're playing games with millions of other investors. But you can see that there's some resemblance, and that's another technique that comes to mind as the latest frontier, deep reinforcement learning. So that's a lot of machine learning researcher, financial researcher are looking into as well. Numerous books have been, written about it as well.
I like what you said there about you're learning to learn. It's a very weird concept, but I know exactly what you're talking about. I was on a podcast, I think at this point, maybe a year ago, that focuses around SEO and different types of content optimization. And their first question to me was, "Hey, what do you think about AI in SEO? Is that the end of SEO?" And the answer is like, no, it's a new way. You have to learn how the machine learns. And now with all of this machine learning, large language models, and AI being turned into this crazy, everlasting gobstopper of technology. GEO is something new that I have to dig in and talking about reading a new paper every day and you still will not even chip away at the iceberg is the best way to put it. There's so many things you have to learn about how the machine is learning and it's changing at such a crazy rate that it's wild out there. But it was great having you on. Thanks for joining us, Ernie.
It's a great talking to you as well. Thank you.
Sure. So, as always, listeners can learn more about an array of financial topics for free at Interactive Broker/Campus. Follow us on your favorite podcast network and feel free to leave us a rating or review. Thanks for listening, everyone.
The analysis in this material is provided for information only and is not and should not be construed as an offer to sell or the solicitation of an offer to buy any security. To the extent that this material discusses general market activity, industry, or sector trends, or other broad-based economic or political conditions, it should not be construed as research or investment advice. To the extent that it includes references to specific securities, commodities, currencies, or other instruments, those references do not constitute a recommendation by IBKR to buy, sell, or hold such investments. This material does not and is not intended to take into account the particular financial conditions, investment objectives, or requirements of individual customers. Before acting on this material, you should consider whether it is suitable for your particular circumstances and, as necessary, seek professional advice.